Ever wanted to fine-tune a model with reinforcement learning without learning the hard math first? This quick build, we will use SkyRL, a lightweight model framework to teach a model to get math problems right. This tutorial will consist of 3 steps. First, reserve a GPU and install the packages. Second, run the training on a grade school mathematics dataset. And third, compare the result with the original model. Let's jump right in. Step 1. Reserve a GPU and install the library of SkyRL. Where to find the GPU? I use vast.ai in the console. First, we need to define a template. On the top right, click Create New. Template name to be SkyRL test or any name of your wish. Now, the image tag, let's go to the blog post and copy this command. Use this last image tag, paste it here. Select a tag, use the latest, and for the Docker options, let us copy this entire command, paste it here. Change the disk space to 200 gigabytes because 100 gigabytes won't suffice for the training. Let's hit create and use. After we specify the Docker image, let's choose an instance. For example, 100 with 80 gigabytes of memory. Click run, visit the instance in the sidebar. Instance. Connect to the instance by hitting the Open Terminal access. Copy the first command, either use the terminal or use VS Code or cursor, remote SSH, add new SSH host, copy this command, and click connect. You are now inside the GPU. Step 2. Train your model. This will consist of 2 simple steps. First, prepare the dataset, and then run the training loop. Let's copy the command, git clone the repo, and then cd into the repo. Now we are in. Next, let's download the dataset. Copy and paste. It quickly downloaded those mathematical questions. And finally, for our second step, we will run the script. But beforehand, let us edit the file to change the number of GPUs from 4 to 1, since we just rented 1. And then, if you want, you can change the logger from weights and biases to console if you don't have the account. Inside the code editor, Command O to open a folder, use pwd to get the current folder, Command O and paste in the directory. On the left, examples folder, go to gsm8k and find the run gsm8k.sh file. Change the number of GPUs from 4 to 1, and we are good to go. In the terminal, we can start the training loop. Paste in the bash examples run.sh, hit enter. It's running the examples. Our application is running. It says you can view your project at weights and biases, command and click open this URL. Wow, you can now monitor your training progress in real time. This panel shows the average evaluation score, which should improve over time. As you see, you can also see the loss, which is decreasing as we expected. After 3 hours, my A100 got 30 steps finished. It's always okay to stop the training in the midway, because when you resume, it will just continue from the previous checkpoint. So after a few hours, we can start to see the result. Part 3. See the results. After you are done with training, such as the training loss is satisfied, we can export our checkpoint to a Hugging Face format. Either if the training is finished or you cut the progress in the midway, you can see the model was saved in a checkpoint format. Where it is saved, it's successfully saved to checkpoint to this RAID checkpoints global step 31 folder. But how to use this checkpoint file? We can't use it directly. We have to convert it to a Hugging Face format. How to do that? In the blog post, we can use the script below to export the checkpoint to the Hugging Face format. Click the script, copy this file entirely, And then in the folder, create a new file, save checkpoint.sh, paste in the entire file. To execute the file, let's copy this command and use bash save checkpoint.sh. It will launch another run to save it in the Hugging Face format. Great! Successfully saved the model to step 31 policy in this Hugging Face format. Next, to launch the model, we can use this compare.py script to compare it with the baseline. Open the compare.py file. Let's copy the entire content. New file. Compare.py and paste in the entire file. What will this file do? It compares the baseline, which is the queen model that's not trained on mathematics, and then with our trained model, which used the dataset of grade school mathematics with 8,000 examples. The script will test both of those models on these sets of prompts, such as Natalia sold how many clips and how many are remaining, a set of mathematical questions that normal large language model tends to do wrong. And then we'll run the model by launching it inside VLLM. Because we import VLLM and use the model ID, we'll run through all of these prompts and compare both of the output. Let's see how they do. To execute the script, let's copy this command, uv run this compare.py, hit enter. It will launch both of the models and then compare their results prompt by prompt. For example, prompt 11 is Tobias is buying a new pair of shoes. Let's see how the baseline model looks. It wrote a lot of verbose mathematical equations, such as allowance equals to $5, and then it also defines the variable x and solved a quadratic equation of total driveways equals to 7x and solved for x. It turned out it couldn't even finish the entire prompt because it was too long and exceeded the maximum output size. How about our trained model? It says, let's calculate the total amount of money. Ooh, it's such a one-line clear equation, saying $5 times 3. And for the output, it didn't use a variable x, such as something equal to 7x. It directly used 15 to divide by 7 to get x, which is 2. So this explanation is much more clear and much more decisive comparing to this verbose format of the normal example. If you want to use your trained example, you can call VLM and then pass in your checkpoint and do whatever you want. Yeah, try the SkyRL out and leave in the comment on what do you think of its output comparing to the previous original baseline. If you encounter any error in the blog post, we have all of the 3 troubleshooting parts, such as fail to download the package, also CUDA not found, also for CUDA out of memory. Shout out to this open source reinforcement library, which is free and very fast, and shout out to Han Chen for recommending this project to me. Thank you for watching.